Today I'm going to be doing linear programming problem 34. Nuts Galore sells 2 spiced nut mixtures, grade A and grade B. Grade A requires 7 ounces of peanuts for every 8 ounces of almonds. Grade B requires 9 ounces of peanuts for every 8 ounces of almonds. There are 630 ounces of peanuts and 640 ounces of almonds available. Grade A makes Nuts Galore a profit of $1.70 and grade B makes a profit of $2.40 per unit assembled. How many units of grade A and grade B nut mixtures should be made to maximize the company's profit, assuming that all units can be sold? There are 6 steps to solving the linear programming equation, and those are create a mixture chart, write constraints, determine feasible region, find the corner points, evaluate profit, and form a solution. So we're going to start off with step 1, which is creating a mixture chart. A mixture chart is a way to organize the information that we have from this question. So the way that I set mine up is that I make my grid first, which is what I'm doing right now, and then I'm going to talk about grade A and grade B, which are the 2 different nut mixtures. And these are each going to be on the X and Y axis, so A is X and B is Y. Next, I'm going to create another part of the chart, and this is going to be where we store the other information that we got from the question. So for this question, it's peanuts and almonds, and those are the 2 types of nuts that could be in either grade A or grade B. And both of these are going to be in ounces. And then the final category is going to be profit, which is how much money we're going to make based off of what we plug in for X and Y in our equations. So now it said that grade A had 7 ounces of peanuts. So I put the 7 ounces in that category. And then grade A had 8 ounces of almonds. So I put that in that category. And then for grade B, we had 9 ounces of peanuts. And then for the almonds, there were 8 ounces. And so then we're going to make our third row, which is going to be the amount, like the maximum amount of peanuts and almonds available. So for peanuts, that's going to be 630, and then for almonds, that's going to be 640. And then for the profit column of the chart, we said that grade A makes Nuts Galore a profit of $1.70. And then grade B nut mixtures will make $2.40 per unit assembled. So the goal is to maximize the profit. So in that last column, I'm going to write max, which is to maximize. Step 2 is to write the constraints, and a constraint is a limitation or restriction. So in the case of our problem, the restrictions or limitations is going to be how many of each product can we produce with the amount of materials that we have, or in this case, how many peanuts or almonds. So we're going to write out the equations for that. The first 2 constraints are going to be X is greater than or equal to 0 and Y is greater than or equal to 0 because we are making more than one product and therefore you can't have 0. So the problem states that there are 630 ounces of peanuts available. So we're going to write the peanut problem now. So the X represents grade A and the Y represents grade B. So we're going to have 7X plus 9Y is less than or equal to 630. And that's because we can't have more than 630 peanut products since that's not available to us. So next up, I'm going to do the almond equation. And as you can see, we have 8X plus 8X is less than or equal to 640, which is the limit, just like our last problem, of how many almonds we can use. We have the profit equation, which is used to see how much money we could make based off of the amount of products that can be produced with the limits given. So for this case, it's going to be P equals 1.7x plus 2.4y, because the 1.7 is how much profit you make based off of grade A nut mixture, and then the 240 is based on the grade B nut mixture. Step 3 is to determine the feasible region. And there's going to be multiple parts of this step, which include finding the points that we're going to be plotting, as well as creating a graph and putting the points down, drawing lines, and then finally determining the feasible region. So first, I'm going to be plugging in 0 for both of the equations, but not the profit equation because we're going to save that for later. But I'm going to start off with 7x plus 9y is less than or equal to 630. And I'm going to start off by putting 0 in for y and then solving. So I just sped things up here because it's simple algebra, but basically the 7 times 0 is 0, so that cancels out, and then both sides divided by 9, and then I got to the answer, which is 630 divided by 9 equals 70, so y equals 70. Now I'm just going to do the same thing with the other side of the equation, so instead of plugging in 0 for the x, I'm going to be plugging it in for the y, and I'm going to be using the same algebra steps in this one. This is where I arrive at my answer, so x equals 90. Based on the equation that I just solved, we now have two of the points that will create our first line on the graph. So those are 0, 70, and then the other is 90, 0. Next up, I'm going to do the other equation, which is 8x plus 8y is less than or equal to 640. Here I am writing out both of the equations. So I have 0 plugged in for x in the first equation, and then in the second equation, I have 0 plugged in for y. I got y equals 80, so I just turned that into the point, which is 0, 80. And then I also got x equals 80, which is going to be the point 80, 0. Now I'm testing 0, 0, and to do this, you plug in the 0 for the x and y of both equations. This is significant because both of the constraints need to work properly in order to be graphed and gain other solutions based off of them. As you can see, this resulted in 0 being less than or equal to 630, which does make sense, and therefore the constraint works. The same thing goes for the other equation, and therefore both of these constraints work, and the equation will properly graph. Now, using the points that we found, we're going to graph two lines. I labeled the x and y axis of my graph, and then I put down the intervals, so I'm doing it by tens on both the y and x axis. Since grade A is our x value, we'll be putting it on the x-axis. Grade B is our y value, so we'll be putting it on the y-axis. Here I'm just writing down the points from earlier, so we have 0, 70, and then we have 90, 0. And for the other points, we have 0, 80, and then the other one is 80, 0. I'm marking 90 and 70 as points on the x and y axes and then connecting them with a line. And then I do the same thing for 0, 80 and 80, 0. And now we have found the feasible region, which is where all four of the constraints touch. It's important to remember that there are lines on the y and x axes, and this is because of the constraints that our x is greater than or equal to 0 and y is greater than or equal to 0, but we're going to get into that into our next step, which is to find the corner points. The corner points can be found at the edges of each of the intersections on the feasible region, and so here I am just highlighting them in green. The first corner point is on the y-axis, and that's going to be 0, 70. The second is on the x-axis, and it is 80, 0. The third point is 0, 0. As you can see, the fourth corner point is in an undetermined area, and therefore we're going to have to use a system of equations to determine where it is. And so to do this, we need to take the two equations by the lines that are intersecting, and then use those as a form of elimination. The two equations are 7x plus 9y less than or equal to 630, and then the 8x plus 8y are less than or equal to 640. Now to figure out the x and y, I'm going to be doing elimination on both equations. My first step is to eliminate one of the variables, and I'm going to do that by multiplying the first equation by -8. See, I multiply each variable by -8, so that's going to be -56 minus 72y, and then the 630 times the -8, which is going to be 5,040. I'm multiplying the second equation by 7, and that way I can have the 7 times 8x, which is going to be 56, and it will cancel out with the other -56x. Y times 7 is 56y, and then 640 times 7 is 4,480. So I have my two equations, and now I can cancel them out. Now I could add these two together. So negative 56 plus 56x cancels out, and then I have negative 72 plus 56y, and these are both y, so they can equal negative 16y. And then I take the negative 5040 plus the 4480, and I get negative 560. To get y by itself, I divide both sides by negative 16, and as you can see, that gets me with the answer of y equals 35. So I found y, but now I need to find the other aspect, which is x. So we're going to be taking y and plugging it back into the equation. The equation being 7x plus 9 times 35 equals 630. When you multiply 9 times 35, you get 315, and then I'm going to rewrite the equation and subtract 315 from both sides. 630, minus 315 equals 315, which is just going to equal 7x now. And then to get x by itself, you divide both sides by 7, and 315 divided by 7 equals 45. Now we have the x of our fourth corner point. There's 2 steps left, so we're on step 5 right now, which is to evaluate the profits using the corner points. We can refer back to our profit equation, which is p equals 1.7x plus 2.4y. I'm going to be using the corner points to plug into the profit equation and therefore figure out what the maximum profit is. So I just start out by writing out the 4 corner points. Here I am plugging in 0 for x and then 70 for y, so that's going to be 1.7 times 0 plus 2.4 times 70, which is going to equal 168. Using the same method, I'm going to be plugging in all of the other corner points into the equation, which are going to give me all of the different answers. The final step is step 6, which is to determine which of the profit equations had the highest outcome. Out of all of the problems, you can see 168 is the highest number, and therefore the points 0, 70 are the points that will allow profit to be maximized. And here I am writing the final step, which is to form a sentence of the solution. So I'm saying to maximize profit, they should make 0 grade A and 70 grade B. And this is referring to the nut mixtures. And the 0 and 70 are coming from the corner points that I used to determine the profit, which is $168.